Today's lesson we will discuss how to write equations using parallel and perpendicular lines. The definition of parallel are coplanar lines that never intersect. The definition of perpendicular lines are lines that intersect to form right angles. A review from Algebra 1, slopes of parallel lines are exactly the same. Slopes of perpendicular lines are opposite reciprocal. By opposite, we're referring to the sign. One of them is positive, one of them is negative. By reciprocal, we're looking at taking the value and flipping it upside down as a fraction. A couple of examples. The first one, it says m equals 3. To be parallel to m equals 3, the slope is identical, it's 3. To be perpendicular, we take the opposite. Since the 3 is a positive value, opposite is a negative. 3 can be written as 3 over 1, so flip the fraction upside down as 1/3. Letter B, to be parallel to 1/2, it's the same value. Sorry, parallel to -1/2, it's the same value as -1/2. To be perpendicular, we need the opposite sign. Since that's a negative, opposite is a positive. Flip the fraction upside down, the 2 goes on top, the 1 goes on bottom, which leaves you with 2. The third example, 3/4. In order to be parallel to 3/4, you need the exact same slope, which is 3/4. To be perpendicular to it, since 3/4 is a positive, its opposite is a negative. Reciprocal, flip the fraction upside down. Will the graphs of each line be parallel, perpendicular, or neither? Show work and explain. In order to determine whether lines will be parallel, perpendicular, or neither, you need to determine what the slope is. And the way to do that is to get lines in the equation of y equals mx plus b. Whatever is in the m position is your slope. Y equals 2x plus 4, y equals 2x minus 8. Since the slopes are exactly the same, your lines will be parallel. Letter B, we have a little bit more work to do. Neither equation is in the form y equals mx plus b. So to get it there, I'm going to start by moving the -6. To move a -6 to the other side, I'm going to add it to both sides. That's going to give me 8y equals 6x minus 24. Next thing I'm going to do is divide everything by 8. If I divide everything by 8, I am left with y equals 6 over 8 reduces to 3/4, x minus 3. The second problem in letter B is a little bit simpler in regards to calculation. I need to move the positive 7 to the other side. I'm going to do it by subtracting the 7. Leaves me with y equals 4/3 x minus 7. So we're determining, will the slopes be parallel? Meaning they're going to have the same slope. Or will they be perpendicular, meaning they're going to have opposite reciprocal slopes. The slope of this first one is 3/4, and the slope of the second one is 4/3. They're not parallel. In order to be perpendicular, they need to be opposite, meaning one has to have a positive value and the other has to have a negative. Both of these have positive values, so they're not opposite. They are reciprocals. In the first one, the 3 is on top and the 4 is on bottom, and in the other, the 4 is on top and the 3 is on bottom. So they are upside down, so that works, but if it doesn't fit both clauses, then it's not perpendicular. So to answer, will the graphs of each line be parallel, perpendicular, or neither? They will be neither, because the slopes are not the same, meaning they can't be parallel, and the slopes are not opposite reciprocals, so they can't be perpendicular. Write the equation of the line given the information. I want you to write the equation of the line that contains this point, meaning it's going to go through that point on the graph. Grab a piece of graph paper and plot it, 3, 2, and I want it to be parallel to this line. So if you were to graph it, you would have 3, 2, so you're going to have this point here, and then you're going to have the line, let's see, it's going to start up here at 7, down 2/1. It's going to come down here like this. So I want you to create a new line that goes through this dot and is parallel to the one given. To be parallel, we need the same slope, which means my slope is going to be y equals -2. I'm going to use, or I'm sorry, m equals -2. I'm going to use this slope, and it doesn't matter which method you use, is slope intercept or point slope. I'm going to do both here just for sake of examples. Y equals mx plus b. The y value is the positive 2 in the point. My m, the x value is the 3 plus b. I need to get the b by itself, so add the 6 to the other side. 8 equals b. My final answer, y equals -2x plus 8. And these canceled right here. Same problem, doing it a different way. Y minus the y value equals my slope, x minus the x value. I'm going to distribute the -2, and now I need to get the y by itself by adding 2 to both sides. Y equals -2x plus 8. And it's because those canceled. Same problem, 2 different ways, same answer. Write the equation of the line that contains the point 2, -1, but this time I want it perpendicular to this given equation. It's not in slope-intercept form yet, so we don't even know what the slope is going to be. Need to do a little bit of calculation. Subtract the 2x from both sides. I get -3y. Be careful with that negative. A lot of students tend to forget it. Next thing I'm going to do is divide everything by -3. Those are going to cancel. Y is going to equal a -2 divided by -3 is going to give you a decimal, but please leave it as a fraction since we're talking about slope. And 6 divided by -3 is a -2. Because we're dealing with the idea of perpendicular, I don't want to use 2/3, that would be parallel being the same. I need to make my slope opposite. So my new slope is going to be the opposite of 2/3, and then I'm going to flip it upside down. So the 3 is on top, and the 2 is on bottom. We're going to use this for slope-intercept, and we are going to use it for point-slope. Same problem, 2 different ways to do it. Slope equals y, slope-intercept form is y equals mx plus b. The y value is a -1. My slope we just discussed is -3/2. X value plus b. -1 equals, this is going to give me -3 plus b. If I add the 3 to both sides, 2 is going to equal b. Final answer, y equals -3/2 x plus 2. And those canceled. If I do point slope form, you're going to have to be a little bit careful here. Y minus, the y value in the ordered pair is a -1. Negative 3 halves is my m, x minus 2. Minus a negative is a positive 1. And I'm going to go ahead and distribute. That's going to give me a positive 3. Last step is to get the y by itself. If I subtract the 1 from both sides, y equals negative 3 halves x plus 2. Same problem, two methods, same answer. Last problem, are the two lines perpendicular? Show, work, and describe. They look perpendicular, but in order to determine whether they are perpendicular, we need to find their slopes. So the slope of line A, I'm going to start right over here, if you can see my purple dot. I'm going to rise 1, 2, 3, 4. And I'm going to run 1, 2, 3, 4, 5, 6, 7, 8, 9. This doesn't reduce nicely, so I'm just going to leave it. Let me change colors for the slope of line B. I'm going to start up here, if you see my green dot, and I'm going to rise. In this particular case, because I'm rising down, it's a negative. So down 1, 2, 3, 4, 5, 6, 7. And I'm going to run 1, 2, 3. Well, they're not parallel, and the question didn't even ask for parallel, but they're not the same. They are opposite. One's negative, one's positive, but they're not upside down fractions of each other. So will the two lines be parallel? No, because the slopes are not opposite reciprocals. That concludes your lesson on writing the equation of lines using parallel and perpendicular lines.